What's up, YouTube? It looks like this time I'm only 2 minutes late, so I'm getting better at this whole streamer thing. I'm trying to schedule these videos in advance now. Welcome if it's your first time. Hello, my name is John. I am a mathematics major. I studied mathematics 15 years ago. Then I went into industry, and now I'm returning back to math. I love it very much, and this is a practice stream. So I'm relearning mathematics, and I'm doing it live. We'll do it live, right? And so this is exciting. We are now on our second round through calculus. I've been working in a bit of kind of like a spiral structure through relearning all of mathematics. We've been starting with linear algebra, and I've done one stream on one chapter, and then I did a stream on chapter 1, then a stream on chapter 2, then a stream on chapter 1, 2, 3, then streams on 1, 2, 3, 4, all the way until we got to chapter 10, and then when we reset, we added one chapter of calculus. Then we did 10 streams of linear algebra, and then just yesterday, where's my thing about, here it is. Just yesterday, we started representation theory of finite groups, and I'm so stoked for that. So we have some high school math with calculus, the last thing that you learn in high school, maybe. Some advanced high school mathematics, so we have some high school math, we have some college undergraduate math, and now we even have some graduate level math. Let's go. Different strokes for different folks. So today we're going to practice calculus. It's our second time through, day 2, practicing calculus. I'm working through this wonderful book by Taalman and Kohn. I'm a big fan of this book. I taught somebody as a tutor a year ago. I did a few private lessons with somebody, and this book is just really, really nice. It's written like a book for math majors, but it's an introduction to calculus book. It is not a real analysis book. It's not like a baby analysis book like Spivak or something. But it is written in the style of a book for math majors to teach engineers calculus and to teach everybody calculus, I guess. Like your first introduction to calc. I like it a lot so far. Okay, so we are still in chapter 0. Tomorrow we'll do chapter 1. But yeah, let's work some problems today. So this is a problem-solving focused stream. I do a blend of kind of study with me style material. And last time it looks like we took a lot of notes, which is mostly just hanging out, yapping, chatting while I take notes and work through some. But then I work through examples. Like in the book, y'all, pro tip to you all. Before you read the example, try to work the example yourself, okay? That took a while for me to really internalize and for me to realize. After reading a bit of theory, in a math textbook, there's usually an example to illustrate some concept that the author has described. Try to work that example yourself before reading the solution. Don't read the example as the text and then use the exercises as the exercise. These examples are worked exercises. You have the solution. You can compare your solution to the author's solution, which is wonderful. Hey Levi, what's up, man? I'm doing great. We're starting the next round of streams, and so we're back to calculus today. I forget, were you there yesterday during our fantastic day 1 representation theory stream? It was super fun, man. Okay, so anyways, last time, I'm just reviewing my notes. I'm gonna start using one long note file again. So just reviewing my notes, it looks like last time we got up to section 3, And I think that this was a true exercise. And so I crossed this one out in the book. So today, I want to see if we can do an exercise from every section today. You know, you don't always have to work all the examples before you go to the exercises. That's also a mistake. The way I'm working, I want to work an exercise from every single section. Won't be here too long. No worries, man. No worries ever for that. Good to see you, though. I should also, this portion of the stream is also kind of just small talk. Like, this is the small talk portion of the stream, everybody. And it is the part of the stream that I hope maybe could still be interesting after the fact. Like, maybe this part of the stream, people might want to click the VODs even if they didn't make it live. So, not speaking so much to you, Levi, but to any potential future VOD viewers, welcome. Please do let me know if you like this. Hit the like and subscribe. Here's a little gentle reminder that if you enjoy what I'm doing, that's the best way to help me grow. And it's the best way to make sure that you keep getting the videos in your feed. If you clicked on this and you're still 6 minutes into this video, you might still be on the fence about whether or not this is interesting. Me too. I don't know if this is a waste of time for me or not. I don't know what I'm doing here. I'm making it, or I'm faking it until I make it, right? Like, I'm just making it up as I go. I blended those two phrases together at once. So I'm making all this up as I go, and I'm just always trying to improve. So I always say this in my classical guitar practice stream: feedback is a gift, and if you have any suggestions on how to make the stream better, maybe that's tighter, faster intros, just jump right into an exercise, or more note-taking, more yapping, less yapping, more exercises, more teaching, more studying. There's just so many different design directions that I could go with this channel. But I think I'm blending things. I have a good balance at the moment for my taste, but I'm all ears. You know, I'm here to also listen to what you all want to see and hear. So, but the number one priority is me. I'm selfish. I want to study math. So I'm not going to just do solve competition math problems here. Like, that's not my goal. That's not my career goal. That's not my personal interest. So selfishly, priority number one is I want to study math for myself. And then secondly, I want to put on a pretty cool little study with me radio show, daily radio show thing, which is just a byproduct of me doing the thing. Anyways, let's get into it. Shall we? Let's get into it. Shall we? Where'd I put it? Here it is. Okay. All right. So let's keep going. Last shout out here. Classical Guitar Channel. We have new music. Listen, notice. This is brand new music. This is my recital that just dropped 2 days ago on my Classical Guitar Channel. So if anybody wants some of this study music to listen to away from the stream, thank you. Thank you for your consideration. All right. Functions and graphs. True or false? Functions are the same as equations. False. There are a lot of good counterexamples to this claim. Functions are the same as equations. Nope. Lots of functions that can only be described in words. I mean, we could get pedantic and become philosophers and argue whether or not, like, what is the difference between, verbally defining a function versus an equation. I'm not interested in that. But, like, dude, there are so many non-mathematical functions or non-number functions. Like one of my favorite examples that I came up with recently with a student was the function defined by your state at the traffic light, or the state of the traffic light and your response to the traffic light. Okay? If the traffic light is red, you stop. Right? If the traffic light is yellow, you slow down, maybe. Then stop. Or something, I don't know. Maybe sometimes you speed up when it's yellow, so maybe that's a slightly more complicated state, but let's keep it simple. Red, yellow, green. Green, you put the pedal to the metal and you drive. You speed up, you go. Right? Yeah. Actually, if it's yellow, you sprint. It's the opposite. I know, yeah. I was just thinking, we could split that into two separate things. Sometimes you stop, sometimes you speed up. But then there we go. That's a great little moment of, wait, we can extend this function, and now there's some new state in the world that you have to consider. How far are you away from the traffic light? And now we have a function this pretty cool car function that takes some sort of state in the world, right? And we return an action. And this state is, it's not all state of the world, but it's just, we could map from R, Y, G to all human actions. Or we could map from, if we extended this yellow state into 2, sometimes you slow down, sometimes you speed up. What do we need to do to this function? What do we need to do to the domain in order to make that work? Well, it would be some sort of state of the traffic light and state of your car, maybe. So, I don't know, we could have a new function that takes a pair of states, like the state of, let's give something more meaningful, traffic light, and the state of your car. And then, based on that, we return an action. Right? So we have, maybe this is equal to the other one, but we also have this new definition that's yellow and close. Yellow and close versus so that you speed up. Otherwise, we have yellow and far. And for this one, you slow down. You slow down and then stop. Right? Neither of your cameras are focused. It is now, right? Yeah, sorry, the camera will autofocus, I think, sometimes if I look away. I need to move the music stand, and then... unless we count the cat as a target subject. Yeah, I hope it's obvious by now that the other... I'm not two Johns live streaming at the same time. That would be awesome. If I'm actually... in this Heisenberg uncertainty principle of the quantum state of guitarist and mathematician YouTubers. But yes, so this is a brand new recital that we just recorded a few days ago, and Luna was a prominent character during the whole thing, which is amazing. I love it. So now we're going to have a lot more Luna showing up in this stream. Schrodinger's John. Yeah. Yeah, we can make a lot more Schrodinger's cat jokes now. Anyway, so this is like a little digression, sort of, but not really. Because this is a really cool example of something that, I mean, we can write it down in equations, kind of, but I don't think that these are equations in the sense that this exercise meant. Like, we're used to thinking of functions as equations like x squared plus 1 or something. But functions are more broad. We have functions that we define all the time in programming, like take a string and return the number of characters in it. How many other functions can I think of? Like the time of day and the hour on the clock, right? I don't understand this stuff even today. It's a messed up thing. What do you mean? What are you talking about? You're not confused. Have I lost you, Levi? Have I overcomplicated functions to the degree that I lost the PhD student in the chat? Or are you getting philosophical on me like, I'm still trying to understand functions? They are actually weirder than you even realize. In a beam of light, some photon can behave as particle, some as wave. Oh, we're back to the Heisenberg, to the YouTuber uncertainty principle. Yo, what's up, Ta? How's it going, man? So we're back to calculus. We're back to high school math. And I was just trying to give some descriptions of functions that are non-mathematical. And dude, I will claim that we interact with this function so much more. This is one of the most like real world things I can think of. If a student ever asked me, when am I ever going to use functions in the real world? I'll be like, little Jimmy, you've already used functions probably 100 times today, or 1,000, depending on how we count it. Every time that you're interacting with a software program, software is all functions. Like, we code this to check, like, is this a valid email? Like, we write functions to say, like, is the thing a valid email, true or false, right? Like, true or false. In coding, we write it as bool, but really it's just the numbers either 0 or 1. And, like, your computer is just a bunch of functions. It's just a whole bunch of functions all the time. So, yeah, I geek out about this topic right now because I like it a lot. I like to try to give some examples of real-world functions that people have seen all the time that are not based on numbers. And I'm an iOS programmer. I code iPhone apps. I have an app for musicians called Mujo. Go get it. Mujo.app if anybody wants to help support me as an artist and creator. Mujo.app is a practice journal for musicians. And, well, I didn't actually code this in this because there's not even a user account or anything like that, but most normie, basic, boring apps have username or email and password, right? And a button that says log in, right? Or sign up, either way, whatever. And as programmers, we define functions that says, is this thing empty? Or is this one empty? And based on these two, we either set this to enabled or disabled, right? Like clickable or not, like grayed out and prominent and colorful or gray, right? That is a function. That is literally a function. This would be a very simple version of it. You could also say, you could make this validation function says, is it empty? Does it contain the at character? Dude, there's just like I don't even know where to start because functions are used all the time in programming, but this is one of my favorites. This is a function, in programming we call them validations, but if I simplify it, we are going to take pairs of state of your email text field and your password text field, and depending on that state, we will map to, well, I guess if I'm pedantic, it would be written this way. And I don't know, I'll just call this F. A function defined on the pair of email state and password state, and we return button state. Right? Clickable or not clickable. This is like just one of the most common functions, and nobody ever told me that. Nobody ever taught me that. I had to learn that in the real world, and then I was like, why didn't they teach me functions like this? You know, like I think that there's so many cool non-mathematical functions, and so I actually really appreciate that this is the very first question. This is the very first exercise in Taalman's book. Like, so far I'm very impressed by this book. I think it's quite nice. And the fact that this is the very first question, like, makes me be like, okay, hell yeah, all right. I think I'm interested. Tell me more. You know, it scares me to start a study calculus with me like series that's not based on Stewart. I would probably get a lot more clicks if I had a Stewart series, but this looks way more interesting to me. All right, so let me catch up with chat real quick, and y'all can work these exercises at the same time, if you want, or think about them. PhD student views functions at a much more profound level than the average man. Yeah, I was going to say, Saeed's, yes, I believe that very much. I mean, my mind was going into all sorts of digressions into type theory and, equivalent axiomatic foundations for mathematics and all sorts of philosophy of math, but we don't have time for that today. This is high school math stream. Don't want to confuse the poor high schoolers. So they're usually described as in quantum state in Hilbert space, defined by wave function. Yes. Intuition really breaks at the quantum level thingy. Yeah. I mean, on that one, I was speaking with some amount of experience. This pink book right up here, these are my only two physics books in this whole bookshelf. They're the odd ones out that are like horizontal there. We've got Shankar quantum mechanics and Jackson electrodynamics. Someday I'll try to work at Jackson. Right now I'm just a poser, but I did take a course on that quantum, and I really liked quantum. I really liked solving those math equations. I don't feel like I understood quantum. Like, I didn't get it. Like, I didn't understand why. I didn't understand how, like, I didn't understand why quantum mechanics works. But I learned how to solve the equations, and I think that that's how every quantum physicist, I think that a physics PhD would be like, yes, young Padawan, that is exactly how we all feel. All right, let me catch up. Searched it up, and the top result was your Reddit post. What? Levi's Reddit post about functions? Can somebody link me to that in the Discord or something? I don't think I have any Reddit posts about math. I don't think I've ever posted. Well, maybe a couple responses, but I've never made a Reddit topic about math. The Reddit post might be about my new classical guitar recital. Is that what you're talking about? Oh, the app that I made. Oh, hell yeah, man. Thank you. Yeah, dude, thank you for that. Yes, bro. Mujo could be so much fucking better, dude. It could be so good, but I'm a geek about practice journaling, about deliberate practice, but journaling, like just like little micro, like quantified self, atomic habits, like atomic habits and quantified self, and like lightweight data tracking and journaling through data tracking. Like, I'm not somebody who will like write sentences to journal about my day. No, I'm negative infinity interested in that. But this YouTube video series is a journal. This is my practice journal, like learning mathematics. My guitar channel was always a practice journal of a sense, learning classical guitar. I've built 2 habit tracker apps. Mujo is a practice journal for musicians. There used to be a better landing page when you went to that website, but I don't know, didn't work. Let me be more clear, because a lot of people are not used to that TLD. That's a URL, just to be totally clear. https mujo.app. It's a practice journal for musicians. It's really dope. Very lightweight. Basically, it's just like a metronome with timers in it. Like, if this metronome had 2 buttons that were just timers, like a stopwatch and a countdown timer, and then just with that, you can get a whole full-featured Todoist, or like a Todoist, or another productivity app, like a whole, data tracking and like quantified self kind of data. It's like a productivity app for musicians in a sense, and it could be a lot better. I'd like to restart it someday. Okay, well, let's keep going. Thanks. So next exercise, and let me read a couple more comments actually. I've been programming for some time now, mostly for school, and dev is just weird for me. It's like driving a car when compared to bike. Like in dev, if it feels just mass up stuff already built. Again, my dev XP is only from ChatGPT era. Yeah, you're gonna get me on a side tangent, and we gotta make sure that we finish by 11, because I told my other channel I'd stream then. But I don't know, man. I don't know what I would recommend to new junior programmers now, because it's a weird world now with AI, and like, if you've only learned in the ChatGPT era, oh, dude, I think it's like, we're all trying to figure out how to use AI effectively for building apps, for building software, but then separately for learning. Those are like 2 separate things, right? You're in the learning stage. I think my 2 tips, my advice to you would be to treat ChatGPT like a solutions manual. Like if you Google the name of your book, solutions, you'll probably find some student who's posted all their solutions on GitHub or something, right? Or you could check the back of the book and you can see the answer in the back of the book if the author, put the odd numbered problems in the back of the book or whatever. So you have to try to code on your own before looking up the answer. Like try, and the point is that it's hard. And you have to code without AI in the learning stage. And treat it like do a chunk of time coding without AI and then compare your answers with AI separately. It's just like learning math. It's so similar to learning math. I can't stress that more. That's one thing. Secondly, this has been standard advice for a very long time. Build something. You have to build something. You don't want to get stuck in, you can Google this term, tutorial hell is a thing in coding. Tutorial hell is a thing. You don't want to get stuck doing tutorials all the time. While you're doing those tutorials, what's your dream app? For me, Mujo was never it was never meant to be a startup. I didn't want to get VC money. I didn't want to raise funds and go public with a metronome app. It was a passion project. It was something that I wanted to build for myself because I saw that none of the apps in the App Store were good enough for what I wanted. None of them were simple enough, especially. So while you're doing those tutorials, try to fucking build something, dude. Build something. And it's up to you. It's your personal choice whether you want to open source it and share it with the world, our beautiful sharing, utopia where we all just share everything for free, or keep it private. You still have something that you can talk about with an employer, and an employer's 100,000 times more interested in hearing about something you built than any courses that you've ever taken. For a junior programmer, especially today. And if you can say that you built the thing without AI, or how you effectively, intelligently used AI to build your thing, and that means, in my opinion, this separate mode of working. Build the thing without AI, then compare your answers, and do that in sufficient chunks. I don't know the right split, but treat AI like a solutions manual. You can't learn math if you just jump right to the solutions, right? All right, so anyways, let's keep going. Bijective or one-to-one and onto, yep. Surjective, onto, and injective, one-to-one. Thanks for explaining that. For me, it was chatting with PDFs again for school, and then came ChatGPT. Interesting. Then permutations or functions, yes. Permutations are absolutely a type of function, and you're going to get me on a side tangent briefly. I'll try to do this very, very quickly. We write the set of permutations as Sn. This is the set of symmetries, which are all permutations. Symmetries are permutations, and we write these kind of numbers. This is an element. This is a number. It's an object in S3 or S4 or, anything other than S1 to 1 or 2. Let's just keep it simple and say S3, right? This is an object, and it's just shorthand for the function that says when x is 1, y is 2. When x is 2, the function returns 3. When x is 3, the function returns 1. So this is actually another one of my favorite examples to try to show somebody who's interested in like non-familiar, different functions that don't look like polynomials. This is another type of function, and it's another way that we write functions. I mean, I guess you could say that that's an equation, but So like this is another one. 1, 3, 2. This is also a permutation of the numbers 1, 2, and 3. When x is 1, y is 3. When x is 3, y is 2. And when x is 2, y is 1. So I hope that helps or something. One last one. 1, 3 is also a permutation of 3 elements. And I want to keep giving more stuff here because I'll geek out about this. This is the function defined like this. You can think of a function actually literally as a collection of points, a collection of pairs of numbers or something. Okay. It's not a redefinition. I'm not redefining. Yeah. I haven't given a formal definition of a function, like in terms of real mathematical formalism, but a function is a simpler way of saying this that we teach in like grade school math is that a function is a machine that takes a number and then returns another number, or takes a thing and returns another thing of some sort. So we could have 2 different functions. One that divides by 2, and we could have another function, I don't know, that triples a number and then adds 1 to it, right? So we could have 2 different functions like that. And then, when you give the number 2 to the machine A or the function A, it returns 1. When the machine B, when you give it the number 2, let's go with 3. When you give the number 3 to machine B, it returns 10. But the important thing is that it's a process with some rule associated with it, and it follows a rule. We can think of it as input and output. You give it an X, it gives you a Y. But input and output would be another way to say it. Like, those are just random letters that we've picked that we like for some reason. But a function is more formally, because that will be another question in a moment. Dude, I did not expect to be spending 40 minutes on on part A of problem 1 today, but okay. I will geek out about this because I don't plan on doing a full stream on this in depth on teaching the basic idea of functions, not just to the people in chat right now, but also potentially to VOD viewers, or if I ever stop being so lazy and like clip these and make an edited version of this or something. Too much work, not worth it. These are some examples of functions that are not polynomials, that are not studied in calculus usually. In fact, last thing, I've said this so many times, but last thing that I'll say is that in programming, like email times password returns button state, there is a whole branch of programming and a whole style of programming called functional programming. And not all programming, you know, like all programming uses functions, but functional programming tries to turn everything in programming into mathematical functions. Like, functional programming wants every single bit of logic, every little part of your app to always be a simple machine. You give it X, it always gives you Y. And then you get all sorts of really beautiful mathematical properties that you don't get in other styles of programming. So I think that that's a nice thing to also motivate this idea. There is a whole branch of coding, and you can make a lot of money, you know, if you learn this. And it's very mathematical. And if you're a math major having an existential crisis after getting a bachelor's degree, with honors in mathematics and deciding not to go to grad school and deciding to go into programming, dude, look up something called functional programming. It turns coding into math, and it's actually really, really nice. Like, it's super nice. So, yeah, leave it at that. Domain of every function is a subset of R. False. I already gave some examples of that. The function of email and password. The domain is the left-hand side, like what you give to the function. Yeah. The function that for each x, f of x equals 1 is a one-to-one function. False. This is by definition. By definition, one-to-one means every y has exactly one x, has a unique input. Every output has one unique input. Every global maximum of a function is also a local maximum. Yeah, that one's true, right? If it's a global maximum, it's also a local maximum. I don't think it's worth trying to prove it. I mean, by definition of global, it is the maximum of the function. It's the greatest point of the function. And so by definition, if you have a local maximum, it must be less than the global maximum. Oh wait, no. Then more like if you have a global maximum, it is also a local maximum. If you look at points near, for some definition of near your maximum, every point close to that maximum is less than that maximum. So therefore it's a local maximum. Yeah, anyways, true. Every local minimum of a function is also a global minimum. Nope, that's silly. Let's construct an example. Well, I always like to try to be clever and give like non-smooth examples or like non-whatever examples, but let's not do it. We could build some kind of function that's a polynomial that looks something like this. I don't know. this point here is a local minimum, but it's not the global minimum. And in fact, if I remember correctly, I'm pretty confident about this. Yeah, for sure. This is a local minimum, but the function does not have a global minimum. This function continues. That arrow implies I'm not trying to trick you. Like, it continues pointing down to and keeps going approximately with that shape forever. So this is not a local, or this is not a global minimum. The graph of a function can never cross one of its asymptotes. False. And I like the example. This one is actually just directly in the text. It's really nice. It's a really nice example, I think. What does it look like exactly? It looks something like this. This is a really nice example, a very clear example where this guy crosses the y equals 1 asymptote. Right? So this is a really excellent example, because people will say a loose definition that says an asymptote is a line that the function will never cross, or will never reach, or never cross. And it's like, kind of, but you have to amend that. It can cross, especially horizontal. I don't think it can never cross a vertical asymptote, but it can cross horizontal asymptotes. So horizontal asymptotes are really behavior when x goes to negative infinity, or when x goes to positive infinity. We're talking about something called limits that we'll define later, but we do get that definition of function gets infinitely close to the line, but never reaches it. Right? Something like this is kind of, I think it's accurate to say that this is true if we're talking about the end behaviors. For x becoming very large, whether it's very large negative or positive. When x is very large, this function gets arbitrarily close, infinitely close to that line. Here also, for this vertical asymptote, we do have the same behavior. So, it requires more precision to try to fix this intuitive idea. I wonder if there's a way to fix that intuition definition with and make it a little more precise. The book does give some example, but it wasn't really clear. It wasn't crystal clear, I feel, to me. All right. Average rates of change can be thought of as slopes. True. An average rate of change is defined as I forget if there's a symbol for this, but like average rate of change. Yeah, I forget what the symbol would be, but it's the change in y divided by change in x, right? And an example. I don't know, some random graph that I just drew. If I take these 2 points, here and here, then my change in y is the distance, is this vertical distance. It's like the rise component of the rise over run slope, saying. Change in y, more formally, it's y2 minus y1. And change in x is the run. So actually, I like to do this. So I always put these next to each other. Like, I put this mnemonic next to the more formal definition because we shouldn't lose the idea of rise over run. I think rise over run is an excellent idea, and it's an excellent thing to remember. Just put quotation marks around the thing and just remind ourselves, like, this is a cute saying that helps us remember this triangle right here. And so the average rate of change is the slope of that line, right? Between 2 points. But I chose this interval right here. I chose this interval, this blue interval right here. But I could do the same exact process for another interval somewhere else. If I chose this interval over here, this red interval, well, then what do we get? The same thing. I'll take 2 points, and forgive me for them kind of being all smashed together now, but I think that you get the picture. That, dude, that thing is like way steeper than the other one. And ultimately, we're talking about a number. We're talking about a single number. Rise over run. Like, this is a number divided by a number. And this number is much bigger, is much steeper. It's a bigger number than the red number is a bigger number than the blue number, right? And yeah, dude, what's up, Schlock? How's it going, bro? Yes, I do. Other people, if you want to help me out on something like this, the handle is jcpractices. So this is my second channel, jcpractices math. It should also be in the video description, so you can get to it from the video description as well. And Levi, if you try to send a link, unfortunately, YouTube will block it. But bro, you've been one of the most regulars. I'm gonna add you as a moderator, and you can politely decline if you want to. So, all right, Levi's gonna be blue now until he tells me to change that. All right, let's go. A function can have different average rates of change on different intervals. This is true. I just drew an example here. The blue number is smaller than the red number. All All right, let's keep going. There we go. I did one. Where is it? There's my book. Here's a moment to just, talk about it for a second. I am a classical guitar practice streamer. I have been streaming my practice sessions. Classical guitar is a hobby for me. It's, I've never wanted to go pro a single day of my life, but I'm trying to get really good. I still pursue my hobbies deeply. Like, I love the idea of deep, lifelong hobbies. Like, just because it's a hobby for you, it doesn't mean that you shouldn't take it seriously and pursue it deeply. Like, I call myself an amateur, and I use that word with pride. That means I'm a lover of art, and that means I'm doing it for the love, not the money. Like, the money is not the reason that I practice the guitar. And likewise with freaking graduate level math, y'all. Like, I am, where did it go? I don't have it here, but like this, we just started our graduate level math series yesterday. Like, I don't want to like research this. I don't want to like invent new math. I just want to study the math that we already know. I think we already have enough math, probably. But it's really beautiful, and I still want to learn it and study it and understand it. Like, if I could understand the proof of Fermat's last theorem, I could die a happy man. Like, that's it. I don't need new math. Like, for me, for my purposes, and like learning math, like, if I could understand the proof of Fermat's last theorem, like, that would be amazing. That's like a cool long-term goal that I probably will never reach, and that's fine. That's totally fine. So it's very freeing, actually, I think, to pursue something like this as a hobby. Now, caveat, I do want to preface, graduate level math, studying this for fun. Nowadays, I do want to study and practice high school math for money, actually. Like, I no longer call myself the math hobbyist. I do want to become a high school teacher. So, por qué no los dos, right? Like, why not both? Like, I do want to be a teacher. But you do not need this to teach calculus to high schoolers, right? Okay, all right. Problem 1 done, written in pen. Thank you, everybody. I don't need to show it, but yeah, we're going to cross off and solve every exercise in this book. Let's keep going. We need to move on. What about the ABC conjecture and the drama? Don't care. Literally don't care. Now, let me actually drill into that and give a rebuttal to what I just said. I do actually kind of want to do some research level math, and that would be contributing to formalization of math. I'm a software engineer. I worked at Google. Before that, I worked at Lyft. Before that, I worked at Apple. Well, factually, what's up, Leo Lectures? How's it going, bro? We're back to the math that I understand. The yellow book was hurting my brain, so we went to the red book. No, as planned, obviously. So I just geeked out. Leo, I feel like I would love your reaction. Leo, you should become a reaction streamer and react to my definition of functions and my introduction to functions. I love this book, dude. Problem 1, very, very first exercise in this book is functions are the same as equations. True or false? If false, provide a counterexample. Dude, that's an awesome problem 1 in a Calculus for Engineers book, I think. Like, that's a great problem 1. And I just, like, geeked out for, like, 20 minutes, and you've probably heard me rant about this in some variation before, but like, dude, what if you're at a traffic light and it's red, then you stop. If it's yellow, you slow down. If it's green, you go. Oh, wait, we can extend the domain. If you're close, then you speed up when it's yellow. If you're far away, then you slow down. What else? Email password login, like coding, functional programming is a thing. Like, I don't know. I like tried to define functions that are not based in numbers, and I think it was kind of cool. I'm going to link to it for my high school applications, maybe. For me, it's always speed up, no matter what. Yeah. Anyways. Hey, Leo, I don't know if you saw my new thumbnail. I finally updated that god-awful thumbnail of our impromptu chat. Have you seen that yet? Go check it out now. I hope you get a kick out of that. RGB, I don't even look at the light. What is blue? I would not know what to do if there was a blue light. Open up another tab, bro. I hope you enjoy the new thumbnail. All right, let's go. 0.2. Problem 0 is always read the section and make your own summary of the material, which is that's a great problem, problem 0. All right, is the first problem always a true false though? Because these take a while, dude. 1004. I like to be strict about this and do, yeah. We went with the K-theory font on this one. I hope you enjoy it. Operations. Transformations. And inverses. Okay, so let's find a systematic approach through this thing. In section 1, we solved a concepts problem. The book separates all of the exercises into concepts. And then the next block is... So there are 20 concepts problems, but I wouldn't want to do 20 streams before doing our very first skills problem. So we'll do the first concept problem from section 1, then the first skills problem from section 2. Gotcha? All right. F of x is x squared plus 1. G of x is 1 over x minus 2. And h of x is square root of x. Now it says, find the domain for each exercise from 21 to 29. So the first exercise is f plus g of x. Like, I think that this is a really cool chapter for a pre-calc, like to teach pre-calc from. Like, it's really clear to me. I think it's like really, really well done. All right, so let's get a little picky about style here. All right, so the question asked about f plus g of x. Solution. F plus g of x is defined as f of x plus g of x. And this would be x squared plus 1 plus 1 over x minus 2. And this is defined, this rule is defined for all x not equal to 2 or something. So the domain, I'll just say that this is the domain. And you know what? At the precalculus level, I think x not equal to 2 is a perfectly good way, and even a better way to write a domain rather than union interval notation. So, there's my hot take. There's a domain of that function, and we could also notice that because this is the addition of two functions, we need this part to be defined, and then we add this other part. So it actually turns out that this is the same as the domain of f and the domain of g. Like, for this addition to be defined, we need f to be defined and g to be defined. So, you know, even if we didn't have the exact rules and all we were told was that the domain of g is the set of all x not equal to 2, and the domain of f is all real numbers, I could still tell you that the domain of f plus g is what happened here? Is the set of all real numbers not equal to 2. Probably will do React to some talk or this textbook a viewer sent me tonight or tomorrow. That would be super cool. I want to see a Leo React videos. Like that actually would be really cool. I think that you would have some good takes. It's not my style. I can't do it. It doesn't work for me. I'll react to textbooks like that. I'll try to react to textbooks, but you were there though once, I think, Leo. Like, this is a deep cut. I think that the video is unlisted and everything, but you were there when I did a reaction stream to City Tutoring. I think you were there, or it might have been Ben. But I think that you asked, like, are we talking about City Tutoring? Yeah. Back when he had like 1,000 subscribers and before he blew up. Yeah. All right, let's go. So first it said find the domain, and then it said then find an Then find an equation for the function and calculate its value at x equal 1. So I wish I had read the rest of that sentence, because mathematicians are very precise. In this problem, Taalman asked, first find the domain, then find an equation, then calculate, if you can, its value at this point. So, you know, a teacher will probably accept my argument 1 in white, but Taalman was actually kind of secretly hinting to the reader, if you really read closely, I think that she was hinting, by the way, you could actually calculate this before writing down the equation, which is actually super cool. So she was hinting that you could take the blue argument. That's super cool. I think, dude, I am going to look this up. It's in my mind that her pronouns are she, her. But I could be completely wrong. This might be a dude. I don't know. Taalman, calculus. What is this person's name? Laura Taalman. Maybe I'm just assuming based on the name Laura. But I wanna confirm this before I say it like 1,000 more times. Does she list her, or I should say, do they list their pronouns? Okay, Wikipedia uses she as pronouns, so I should. Oh, and her handle on Blue Sky or something, or her website is mathgrrl.com, mathgrrl.com. I feel very proud that I thought to check on this, and it turns out that she's a super she, her pronoun adopter. Awesome. Let's keep going. For a second, I was like, I could be completely wrong, and this actually might be like a scruffy looking dude. All right, let's go. An equation for the function, calculate its value at x equals 1. That was the last part. All right, so f plus g at x equals 1. This is part 3 of the problem. This part was part 2 of the problem. This part was part 1 of the problem. F plus g computed at 1. I could go that this is f of 1 plus g of 1, which is 1 squared plus 1 plus 1 over 1 minus 2. And if we think really hard about that, this is 2 minus 1, which is 1. So we're done. And I get to cross out a problem from section 2. Never doing that problem again. Written in pen and everything. How's it going, everybody? So somebody was asking about the guitar channel. I wonder, I hope you enjoy. This is a brand new concert. This is a brand new recital that I streamed just a couple days ago. So I hope that you all enjoyed the new background music. There were a couple of pretty bad mistakes that came up. So, you're going to hear those mistakes again and again forever. But at least on the flip side, we got a lot of Luna in this concert, right? There's a lot of Luna, which is a happy accident. But yeah, she ruined my first take of the first piece during the whole concert. She dropped the mouse on my foot, and I had to stop and restart the whole concert. And I was just like, all right, this is how this is going now. Thank you, Luna. You're so cute. Anyways. All right. I hope I wasn't offensive just now about the pronoun checking. I was actually genuinely, truly wanted to make sure I was using the right pronouns there. Leo said that he's going to react to a textbook that a viewer sent. I want to see your reaction and K-Theory's reaction to this book, because I think it's so good. I like it a lot. And I commented on one of his videos saying, because he had a video with a pretty standard take that was like, oh, for undergraduate calculus, your options are Stewart or Spivak. I learned from Stewart. I hear that Spivak is good, but I don't know. There's not a great calculus textbook. I think that this is actually a very good book that's in between the two. Between Stewart and Spivak. Closer to Stewart than Spivak, maybe, but no, maybe not. I don't know. Maybe perfectly in between. Section 3, algebraic functions. We've already crossed out a few from problem 1. Let's go to applications. Okay. So now we're going to do an applications problem from section 3. Oh, yeah. Section 3 is about algebraic functions. Hello, I am back again with linear algebra questions. Nice. Well, you tuned into the wrong stream because today we're doing calculus. What's up, Sudeep? What kind of linear algebra are you working yourself? Dude, good to see you. What questions do you have? I might answer them. All right, algebraic functions, section 3. You probably know this math better. We are now going to do an applications problem. This is problem number 81. The following table for exercises 81 and 82 describes the number of cars that were on a particular 1 mile stretch of Route 97 at T hours after 6 a.m. Monday morning. Ooh, all right. So we've got a table that says number of cars on a 1 mile stretch. Doesn't matter what route it was, but T hours after 6 a.m. Monday morning. And then that's repeated in this little table, so I'll just write it here. T, which is the number of hours after 6 a.m. That looks like a plus. How do I fix that T so it doesn't look like a plus? And then N is cars, number of cars on road. And we have the values 0, 1, 2, and 3, which map to the values 0, 28, 12, and 18. Okay. So, just like in those other, in the definition of functions that I was giving earlier in this stream, I was defining that it's actually very mathematically precise to say that a function is a table of values. It might be an infinitely long table, but a function is a list of points. A function is a mapping from x to y. Now, not every one is a function because you should only have one x, or you should only have one y for every x, but still, like, it's still a collection of pairs. We don't need to split this. It's fine. We'll just do one split. No. We don't need no split. All right, let's say make a plot of the data given in the preceding table. Suppose you wanted to find a polynomial function n of t. Suppose you want a polynomial n of t that passes through each of the 4 data points. I'll say fitting the data. Same thing. What is the minimum degree that this polynomial function could be, and why? Huh, nice. What is the minimum degree, and why? The book is more precise for those pedantic people out there. What is the minimum degree and why is not mathematically correct, but it's, what is the minimum degree that this polynomial could have and why? All right, so part 1 says make a plot of the data. Part 2 says, what is the minimum degree and why? We could answer 2 without making the plot, but let's do it. Solution. Okay, well, we can't have a negative number of cars on the road unless you're like really clever about it. So I'm not even going to draw a negative y-axis. We could have negative hours before 6 a.m. Like negative 1 hours after 6 a.m. is 5 a.m., right? But this table doesn't include that. But we still want a polynomial, right? So I will still keep some little bit of both of the negative parts of these axes. But I want to give myself some space here to fit 0, 1, 2, and 3. We have at point 0, or at time 0, let's see, red. At time 0, we have 0 cars on the road. At time 1, we have 28 cars on the road. So the maximum number that this function takes is close to 30. So I'm going to go with 3 tick marks again. And each of those represents 10 units. When I'm drawing plots, if the axis is not 1, 2, 3, then I like to put what the units are, and I default, if I don't write the units, we're assuming 1, 2, 3. I don't know if I've seen other people do that, but I think it makes sense. I think it's nice. So there's our plot point 0, 0. Just plotted the point 0, 0. Now we're going to plot the point 128. I suppose if I write the ordered pairs in colors, we don't need them there. And then we're going to plot 212. And then we're going to plot 318. Right? Okay. So 128 would be very close to 30. 212 would be a little above that 10. 318 is in green right there. So I'm feeling like I'm kind of self-conscious about this semi-joke earlier. None of it was intended to be a joke. I was truly trying to make sure that I was correct in my language because it's important. It is important, and I very much do respect. Yeah, I find pronouns very important and want to respect that. So I wanted to make sure that I was using the correct pronouns, which is important. Yeah. All right, so here's one function that could map through all these points. I guess I've painted myself into a corner where I need another color, don't I? Or I'll just use white. All right, so white could be going up, maybe it goes down like this. I don't like that I'm kind of implying that you know what? I don't want to be clever. I think it would be something like this. Now, I drew this in a way where the beginning was realistic and the ending was unrealistic. I kind of mixed the two purposes here. So let's actually try this again. Okay. So we've got, I'm kind of getting a little overkill now, but 7 a.m., 8 a.m., 9 a.m., and then, you know, maybe lunchtime increases a little bit. Around 3 o'clock, there's not that many, and then it really spikes around rush hour or something. This is a polynomial function that could be representing this data. And this is a somewhat realistic sort of, like in the middle of the night, there's not as many cars on the road. Well, maybe not at 5 a.m. There's probably some, but we got to move on. This is a somewhat realistic plot, and it is a polynomial. All parts of it are smooth. We have local minima, local maxima. I don't know. It's a complicated polynomial, but it's a polynomial. And so, you know what? Wait. Make a plot of the data. It didn't even ask us to draw an example polynomial. It just said, suppose we want a polynomial that fits the data. What's the minimum degree and why? Okay, cool. So this would be like a sort of realistic a somewhat realistic plot. But if we took the same exact plot that we were actually asked about. Oops. We were just asked to make a plot of the data. So there's our plot of the data, and I made a kind of realistic fit. But now this time, if we want a minimum, we have at least a local max somewhere around that blue dot. And then we have a local minimum somewhere around this yellow one. Like, we're guaranteed to have a local max and a local minimum because we have following points that are less than the blue and another point that's greater than the yellow, right? So if I want a minimum polynomial, a minimum degree polynomial, it might look something like this. You know? So, on day 1, there's 0 cars at 6 a.m. and then on day 2, there's going to be like 1,000 cars at 6 a.m. So something feels wrong. This is not a realistic plot, but that's the point. That's the whole point of this exercise and of exploring this example where a minimum degree polynomial is only going to fit these points well. It will not work very well for future data points. Like, it is not going to predict 0 for the following day at 6 a.m. Like 24 hours after 6 a.m. How's it going, Sensei? What's up, man? Oh, and Sudeep, I apologize if I missed you. I should have responded to your thing. You said row elementary operations. What's the significance of it in a system of linear equations? Whew, dude, that's a big topic. Sudeep, if you're still... Oh, you're still there. Okay, good. Well, you're going to make me take a little tangent, but it's a perfect timing because we just finished this exercise. So I'm going to write it in pen in my book. Done. This is... Here, let's write the conclusion. Therefore, minimum degree of a polynomial. It's important to say that this is a polynomial function that we're assuming. The minimum degree... Oh, shoot. What would it be? Exactly. It would be at least a cubic. Right? No. Okay. It needs to be odd because odd functions have different signs in their tail and in their endpoints behaviors. So to the left, it's pointing down. To the right, it's pointing up. So it's an odd function. And it has two local extrema. So is that enough to say, if I read the section, there's probably a really nice, cleanly organized theorem that I can cite here. But the minimum degree, I believe, on this bad boy is 5. Is that right? Or is it... Can you get a cubic that looks like this? You can. Yeah, you totally can. No, it's 3. It's 3. Of course. Yeah, you can get a cubic that has that shape. I can construct one. I can construct the polynomial with zeros at -1, 0, and +1. This essentially has the same shape, and I could redraw my polynomial from... Yeah, I should be able to cite this. Okay. Yeah. This is the polynomial p of x equals x times x plus 1 times x minus 1. I know that because these are the 3 zeros of the polynomial. X equals -1, x equals 0, and x equals +1. So if I write this polynomial in factored form, then that's how it is in factored form. And just for funsies, this would be x cubed minus x. Gets us a polynomial that looks like this, which is essentially the same shape, the same important features as this polynomial that we sketched. And I think that in general, if you have n local extrema, like in this we have 2 local extrema, local minimum and local maximum, then that implies, I believe, that your polynomial that the degree of your polynomial is greater than or equal to n plus 1. I guess we could say degree of your polynomial is greater than n. But don't quote me on that, because I don't know, I think that's right. Okay, let's keep going. So, Sudeep asked about linear algebra and row operations. It's so important, man. Like, it's so important. When you're solving systems of equations like this, the way that we usually teach people how to solve these, there's 2 ways that we teach people how to solve these in high school. The substitution method, where we would maybe say that x is 3 minus 2y, and then you find 4 times 3 minus 2y plus 5y equals 6, ... right? This is like the way that you first learn how to solve these systems of equations. You substitute, you solve for one, and then you substitute into the other equation. But that doesn't work well in 3x3 systems. It gets very confusing very fast. So the other approach is elimination. Yeah, you just said it too. Substitution and elimination. So you've seen those words, and you know that these are the 2 approaches. in elimination, I like to put like a little circled 1 and a circled 2. And then I say that like the new equation that we can rewrite that system as, well, maybe we keep the first line the same, and then the second line, maybe we subtract 4 times the first line, right? 0x plus 5 minus 8 y equals 6 minus 12, right? And, well, of course, 5 minus 8 is negative 3. 6 minus 12 is negative 6. Did I get that right? Yeah. And then we rewrite those two equations again as y equals 2. X plus 2y equal 3. And finally, you do the same thing as in the substitution method, but this time you can think of it as row 1 minus 2 times row 2. X plus, x plus 0y equals 3 minus 4, which is negative 1. Y equals 2. So we could maybe just erase that. X is negative 1, y is 2, right? So in the elimination method, I'm already biased toward writing these, rewriting every equation every time. And you may not do elimination exactly the same way, but the normal way to do elimination is still doing the same thing. It's just that I'm just trying to keep everything organized and rewrite the whole system every time, right? The reason that I like to do that is that if you do that, then you can simplify. Like, we could use any letter, X and Y, or alpha and beta, A and B, smiley face and frowny face, anything that you want. Then the only part that matters are the coefficients. 1, 2, 3, 4, 5, 6. And then we rewrote, we eliminated the 4 in the bottom left. And we got negative 3, negative 6. Then we rewrote the system as 1, 2, 3, 0, 1, 2. And then we rewrote the system as we eliminated y in the first equation. So 1x equals negative 1, and 1y equals 2. Right? So this is just a different notation, but it's so much simpler. It's so much cleaner and neater. Like, these arrows don't need to be so long. I could have had them like much closer. It's much easier to write down. And analogously, it's just as much easier for computers to do. For computers can calculate on blocks of numbers so much better than lines of equations. And we've built GPUs which are really efficient. GPUs are really good at this. So I hope that that helps motivate a little bit about why row reductions are important. Does that make sense, dude? Any follow-up questions? Thanks for the new fact. Hell yeah, dude. Hell yeah. Okay. Very last parting thought here. GPUs are really good at doing these calculations, and that's why they're so expensive right now. Okay? They're so expensive today, not because our video games are getting really complicated. That's why we invented GPUs, so we could play games. But now GPUs are very expensive because ChatGPT works with giant blocks of numbers. ChatGPT is doing this kind of math. Like, it actually is. Lots of engineering problems are doing this exact kind of math. But it's not a 2x2. It's not a 3x3. It's not 300 by 300. It's humongous. It's a billion by a billion or something. Yeah, what's up, Ryu? Ryu, please. Yes. I'm in a quantum state right now of math and classical guitar. I'm in a weird superposition of a quantum state as a creator, as a streamer. How's it going, dude? The trick is that someday you won't even know. The math will be the replay and the guitar will be live. You won't even know. All right. Okay, cool. So I hope that that helped motivate a little bit why row operations are important. Yeah, I'm familiar with AI and ML. Yeah, dude. That's sick ASL. What is ASL? I know ASF is like as F, right? But what is ASL? Back in my day, that meant something different. Let's keep going. All right, we did the application problem. I think that we're just about done for today. In 10 minutes, in fact, I'm going to practice classical guitar. So I welcome you to join me practicing classical guitar if you'd like. Waiting for your coding stream too, sir. I should claim the name jcpractices code or jcpractices coding or something. I should claim it, but like, no joke, you all would have to pay me a lot to do that. Like, I'm very good at coding. I'm an expert at my little corner of coding, and I don't know. I don't code for fun anymore. I used to code for fun, not anymore, dude. Like, you all would have to pay me. People would have to pay me a decent amount to do that, but I'll do it. Like, that would be really cool. But like, math, it doesn't matter to me whether or not this grows. It's okay to me if it doesn't succeed, if I don't blow up and become a viral internet celebrity, because I just want to study math as a hobby. Like, math is a hobby for me. Classical guitar is a hobby. I want to get good at these things, and I think streaming is making me better at them. Don't really want to code as a hobby anymore, you know? All right, but I got fried because I was doing photosynthesis. Ooh, like studying photosynthesis? That sounds interesting. JC practices math and coding. We probably do JC practices gaming before I do JC practices coding. Little shout out. I have a baby channel in JC practices gaming. So if y'all are interested in that, there's like, it's not very active, but I do have a couple of gaming streams where I play like a music rhythm game live. If people want it, I could start that one again. I could see myself doing jcpractices Vim. Not coding, but Vim. Like, just, I want to get really, really good, like stupidly good at Vim. Yeah. I would love to get stupidly good at Vim. Like, not to solve any problems, because like nowadays to code, you type English sentences to ChatGPT. Back in my day, we hand chiseled our code with a arcane old tool called Vim, and it was beautiful. It was really lovely. But, you know, Vim might become an art form. Vim might become like classical guitar. It might become a pointless activity that we do just for fun, because it's absolutely beautiful and fun. So we are learning discrete structure in this semester, and man, my logical skill hit rock bottom when I try to solve a problem. Welcome to mathematics. Mathematics is humbling, dude. Mathematics will humble you. You think that you know what you're doing? No. No matter what level you're at, there's always math that will humble you and make you realize, like, oh no, I don't know anything, actually. I don't know a single thing. I thought that I knew things, but I don't know anything. The trick is to find fun and joy in that. To find joy in the fact that you don't know anything. Like, it's a very rewarding, freeing realization once you get there. Like, I don't know anything. I'm stumped on this problem. This problem is very hard. And that's what's fun about it. So, yeah. You have a gaming channel too. I do. I don't really use it. But some people want me to start it again. It's tempting. What else do you do? I really just do guitar and math. The gaming channel was an offshoot of me practicing guitar, actually. Because I needed to... My teacher kept telling me that I need to work on my rhythm. That I need to work on, like, my... Like, I need to get, like, this... Like, the rhythm of a drummer or of, like, a metal guitarist. Like, perfectly on the grid... Da, 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 you know, I can't even say that. Like, I don't have perfect rhythm. And my thought was, okay, hell yeah, I love this rhythm game called Rhythm Doctor. And for a while I was practicing Rhythm Doctor. But yeah, I just realized at some point, like, it kind of loses the point. Because the point is that I'm deliberately practicing, and that these streams are deliberate practice. Maybe it's teaching, maybe it's math, maybe it's guitar. It's some blend of all of those things. Maybe it's the ability to talk to a camera. But there's like a lot of deliberate practice happening here. And I don't actually want to be a gamer. I don't like video games that much. But I want to get really good at this one video game for the sake of guitar. But then it doesn't deserve its own channel. If it's a lemma to that theorem. You know what I mean? Everyone hits a wall in math, and personally I think no one really breaks that wall. It's just shifting forward and forward. Absolutely. Very true. Very true. Totally agree with that. Yeah, man. Well, this was fun. Thank you everybody for hanging out with me. It was an absolute pleasure. Please do like and subscribe, and if you know anybody who might be interested in this super niche, super nerdy, geeky thing, invite them. It was fun to practice a little bit of calculus, really pre-calculus today. Tomorrow we will do another day from this book, and we will begin true, proper calculus tomorrow. So I'm excited. We're going to define the limit. We will get some exercises. I hope that we can get the formal definition of the limit, section 1.2, and then section 1.3 is delta epsilon proofs. It would actually be very cool to work a epsilon delta proof. Why does she call it delta epsilon proof? Like, nobody in the world calls them delta epsilon proofs. It's epsilon delta. There's some sort of like, well, actually reasoning here. Like, delta implies epsilon? No, epsilon defines delta. Huh. Or like, delta depends on epsilon. Is that why she would say delta epsilon proofs? I don't know. Yeah, anyways. Because most people say epsilon delta. So that's actually really curious to me. But it would be cool if we could work a epsilon delta proof tomorrow. And then we have continuity and its consequences. What am I doing? What am I doing here? We can go right here. Tomorrow, we're going to be talking about limits. We've got an intuitive introduction to limits, a formal definition of limit, delta epsilon proofs, continuity and its consequences, limit rules and calculating basic limits, and infinite limits and indeterminate forms. Like, I think that this is such a cool book. It has this optional chapter. It's clearly marked with a star next to it. Section 1.3 is an optional section in this book because not everybody needs to know epsilon delta proofs. But she does not say that formal definition of limit is optional. She says everybody should know the formal definition. Now, whether or not you can use and prove things with that formal definition, that's up to your teacher. But I don't know, I think it's really cool to have an optional section in the middle of the chapter rather than putting it at the end of the chapter. Like, organizing it in a way that's like, you can and should, if you want to, if you're interested, learn this before you learn all of these recipes of how to use the limit regarding limit rules in 1.5. Like, I think that this book is really clearly, neatly organized. Yeah. All right, so hopefully we'll get to some of this tomorrow, probably just sections 1, 2, and 3. But yeah, it was a pleasure. Thank you everybody for watching, and take care. I would raid K-Theory, but we're going to raid myself now instead. So join me if you'd like to for my classical guitar practice stream. I'll be practicing classical guitar, and I'm going to actually be somewhat focused. So we're going to try a new structure in my guitar channel, which is more of a pomodoro style session. I'm actually going to focus and work for 25-minute blocks, just like how K-Theory does pomodoro streams. And yeah, I don't care. I don't care if it tanks my channel's engagement. I guess I just don't care anymore. I want to get more efficient at guitar, and I think some people really might like it, actually. So give it a shot if you're interested, and it was a pleasure. Thank you for watching. Bye. Bye, everyone.